Now let's take problem based on psychrometrics. So first I am writing the problem and then we will see how we can solve this problem. The air supplied to a room, the air supplied to a room of a building in winter of a building in winter is to be at 17 degrees centigrade is to be at 17 degrees centigrade and have a relative humidity and have a relative humidity of 60% of 60% if the barometric pressure is if the barometric pressure is if the barometric pressure is 1.01325 bar, find number 1 the specific humidity, number 2 the dew point under this condition, the dew point under this condition. So now for this problem we have to find out specific humidity and dew point temperature. So now let's solve this problem. So whatever given data I will write here first, that is dry bulb temperature, that is denoted by T dVT equals to 17 degrees centigrade. Relative humidity is given, that is 60%. Relative humidity, that is denoted by 5, 60%, that is 0.6. Total pressure, that is barometric, means atmospheric pressure. So P is given, that is 1.01325 bar. So now we have to find out specific humidity. So for specific humidity we are using the notation W. So now at 17 degrees centigrade we have to find out corresponding pressure. So at 17 degrees centigrade saturation pressure of pure water, that is denoted by PS equals to 0.0194 bar. 0.0194 bar. These things we can get from steam table. So I am writing here from steam table. But from GATE point of view, they will directly give the data or they will provide the table itself in the problem. So now we are having PS, that is 0.0194 bar, and we are having the specific, we have to find out specific humidity, but we are having relative humidity. So for relative humidity, that is 5, we are having formula PW by PS. So now we have to put the values in that formula. 5, that is given 0.6 it is given, equals to PW, that is partial pressure of water vapor, we have to find out, and we are already having saturation pressure of pure water, that is PS at 17 degrees centigrade, that is 0.0194. So now with the help of this formula we can get zero point 0.6 into 0.0194, so it will come 0.01164 bar. So the partial pressure of water vapor is 0.01164 bar. But we are interested in specific humidity. So now for specific humidity, that is denoted by W, we are having the formula 0.622 PW divided by P minus PW. So now W equals to 0.622 PW, we are having 0.01164 divided by P, that is total pressure, that is given 1.01325 minus PW 0.01164. So if we calculate this thing, we will get W equals to 0.00723 kilogram per kg of dry air. So the specific humidity in that problem will be 0.00723 kilogram per kilogram of dry air. Now let's calculate dew point temperature. So now we are interested in dew point temperature, that is denoted by dew point. So now I will again draw TS diagram which is already discussed during theory. So I am again drawing this TS diagram. In TS diagram we are having these two things. So here we are having PS, here we are having PW, here we are having dry bulb, and here we are having dew point temperature. So now if you see, the dew point temperature is nothing but saturation temperature corresponding to PW. So I will write dew point is saturation temperature corresponding to PW. So PW equals to 0.01164 bar. So now from steam table, saturation temperature corresponding to 0.01164 bar, 0.01164 bar is 9.18 degree centigrade. So the dew point temperature in that case will be 9.18 degree centigrade. Another problem. So first of all I am writing the problem here. 0.004 kg of water vapor per kg of atmospheric air per kg of atmospheric air is removed and temperature of air after removing the water vapor removing the water vapor becomes 20 degrees centigrade, becomes 20 degrees centigrade. Determine first relative humidity that is denoted by phi. Second, dew point temperature, dew point temperature. Assume the condition of atmospheric air, assume condition of atmospheric air is 30 degrees centigrade, is 30 degrees centigrade and 55% relative humidity and 55% relative humidity and and pressure is 1.0132 bar. So now let's solve this problem. So here dry bulb temperature is given 30 degrees centigrade. So dry bulb is given 30 degrees centigrade. So from steam table saturation or saturation pressure of from steam table saturation pressure of pure water at 30 degrees centigrade is 0.0425 bar. So from steam table we can easily get saturation pressure of pure water at 30 degrees centigrade, that is 0.0425 bar. So that is PS 0.0425 bar. So we know the relative humidity is nothing but PW divided by PS. So relative humidity phi equals to PW by PS. So for atmospheric air, phi equals to 55%, that is 0.55. So I will put 0.55 equals to PW. PS is given 0.0425. So I can easily calculate PW equals to 0.55 into 0.0425. So it will come 0.02337 bar. So PW is coming 0.02337 bar. Similarly, we can calculate specific humidity. So specific humidity, that is W. So W here we can calculate by 0.622 PW divided by P minus PW. So W equals to 0.622. PW here we are having 0.0337. P, that is atmospheric pressure, is given 1.0132 minus again PW 0.02337, and if we calculate this thing, it is coming 0.01468 kilogram per kg of dry air. So this is we calculate for atmospheric air, which is at 30 degrees centigrade and 55% relative humidity. This one is the specific humidity initially, that is for atmospheric air. Now in the problem, 0.004 kg of water vapor per kg of atmospheric air is removed. So now we have to find out specific humidity after removing 0.004 kg of water vapor. So now I will write the specific humidity after removing 0.004 kg of water vapor. Suppose I am denoting these things with W dash, so the specific humidity will be 0.01468, that is initial, and we have to remove 0.004. So now the W dash will be 0.01068 kg per kg of dry air. So this one is the W dash, and now the temperature that is given 20 degrees centigrade. Temperature that is dry bulb is given now 20 degrees centigrade. Suppose that is T dash 20 degrees centigrade. Now again the partial pressure of water vapor we have to calculate. So now we have to calculate partial pressure of water vapor. So partial pressure of water vapor that is denoted by PW dash at TTV dash equals to 20 degrees centigrade, and specific humidity that is W dash equals to 0.01068 kilogram per kg of dry air. So now we are having the formula W dash equals to 0.622 PW dash divided by P minus PW dash. Remember one thing, the atmospheric pressure P will not change. So now the W dash we are having 0.01068, 0.622 PW dash we have to calculate. We know the P, that is 1.0132 minus PW dash. So I can write 0.01068 1.0132 minus PW dash equals to 0.622 PW dash. So 0.01068 minus of, that is PW dash, plus 0.01082 equals to 0.622 PW dash. So now we can see it is 0.6327 PW dash equals to 0.01082. So the PW dash will come 0.0171 bar. So the PW dash, that is partial pressure of water vapor at 20 degree centigrade dry bulb and 0.01068 specific. Now saturation pressure of pure water. Saturation pressure of pure water, that is PS dash at T TB dash equals to 20 degrees centigrade will be 0.0234 bar. So that is the saturation pressure of pure water. Now we have to find out relative humidity. So relative humidity in that case will be phi dash equals to Pw dash by Ps dash. So phi dash will be Pw dash 0.0171 divided by Ps dash 0.023 bar. So now this value will come 0.73 or 73 percentage. So now dew bulb temperature, dew point temperature, dew point temperature. It is T dew point dash. So we are having Pw dash, that is 0.0171. So the saturation temperature, saturation temperature corresponding to corresponding to 0.0171 bar is 15 degrees centigrade. So dew point temperature at this stage will be 15 degrees centigrade. This one is the dew point temperature corresponding to 0.0171 bar. So now let's take another problem. So I am writing the problem here first. A room having a volume of a room having a volume of 112 meter cube is having air water vapor mixture, air water vapor mixture, air water vapor mixture at 38 degrees centigrade. The atmospheric pressure is 1 bar. The atmospheric pressure is 1 bar, and relative humidity is 70%. Determine the humidity ratio. Determine the humidity ratio. So in that problem, a room having a 112 meter cube volume is given, and the temperature is given 38 degrees centigrade, atmospheric pressure that is 1 bar, and relative humidity is 70%. We are interested in humidity ratio. So let's solve this problem. So I am giving the solution. Volume that is given 112 meter cube. The dry bulb temperature, dry bulb that is 38 degrees centigrade is given. Atmospheric pressure, as per our notation P, it is 1 bar is given, and relative humidity, that is 70% means 0.7. So now the dry bulb temperature, that is 38 degrees centigrade is given. So we have to find out saturation pressure of pure water at 38 degrees centigrade. So from steam table, saturation pressure of pure water at 38 degrees centigrade. That is Ts. So Ts at 38 degrees centigrade from steam table is 0.06624 bar. So now we have to find out humidity ratio. But before that, we are having relative humidity. So by this way we can find out partial pressure of water vapor. So now partial pressure of water vapor, that is denoted by Pw. So we know phi equals to Pw by Ps. Phi in that problem is zero point 0.7. Pw we have to find out. Ps is 0.06624. So Pw we can find with the help of zero point 0.7 into 0.06624. So Pw will come 0.046368 bar. So the partial pressure of water vapor in that case will be 0.046368 bar. Now humidity ratio. So now we will calculate humidity ratio, that is denoted by W. So W will be 0.622 Pw divided by P minus Pw. So W equals to 0.622. Tw is 0.04638 and pressure P, that is atmospheric pressure, is given 1 bar minus 0.04638. If we calculate this thing, it is coming 0.0302 kg per kg of air, kg per kg of dry air. So the specific humidity is coming 0.0302.